and welcome back to the RedMars Podcast. I'm your host, AstroJake, and today we are going to be talking about CubeSats. So I wanted to talk about CubeSats today for a particular reason, and I was going through some of my old undergrad documents and books and all that, and I came across one of my old professors, Michel Barbeau, and I remember him talking to me before I made my move to the US, and we were chatting about different technologies in space, and he knew my interest was there. And he mentioned that he was on the board for CubeSats, and that spanned both Canada and the US. And he did a bunch of research in that area and mentioned that, maybe I'd be interested in that. So didn't think about much of it then at that point. I was in the Air Force, but thought it was a cool opportunity to learn a bit more. But then went off to my pilot training in the Air Force, and that kind of was the last of that. And so I thought. Later on in my career, I ended up leaving the Air Force, made my move down here to Florida in the United States, and since I've become a citizen and enjoying it very much. But that brought me over to CubeSats once again. I did my master's degree down here in Florida at the Florida Institute of Technology, and that is where I learned all about space systems and everything like that, even before getting into the space industry. And one of the things I was really curious about is what is a cheaper solution or project that I could work on that could allow me to experiment with the things I was learning while in school. And that got me looking at CubeSats. So we're going to talk a bit about what a CubeSat is, how much do they cost, the materials that go into them, the size of them, and really all different aspects of what a CubeSat is and how you as well could get involved in building one of these out. Now, I've mentioned in previous podcasts that these are cheaper solutions, all relative, obviously, and you can make these as cheap as you want or as expensive as you want. But I have mentioned that there are many tools out there for these types of projects that are readily available to people like you and I. All right, so let's just start things off. Let's talk a bit about what exactly is a CubeSat. Why do I keep mentioning this CubeSat? So let's look at the name itself, Cube. Cube, three-dimensional, looks like a box. It is equal size of the cube, hence cube, and it is 10 centimeters by 10 centimeters by 10 centimeters. 10 centimeters cubed. That is correct, yes. So they aren't big at all, yet they do pack quite the punch. You can store all kinds of avionics inside of these systems, but they are typically designed to have a very specific purpose. So think of a university group that's looking to study, say, some sort of aspect of the atmosphere or the environment here on Earth. They might build a small CubeSat to send into orbit and do some very specific analysis of the atmosphere or something along those lines. Who knows? Maybe they want to do some imaging or test out some cool AI algorithms on filtering through the atmosphere. There are many different types of scientific procedures or whatnot, or really there's anything. You can do anything you want. Really, the sky's the limit. Well, I guess in this sense, space. But it is key to note that they're not really restricted to just the 10 by 10 by 10 cube. You can actually build out these CubeSats in 1 unit, 2 unit, 3 unit, or 6 units. 1 unit is one of those single cubes. Think of a box, and now you need more space. Well, you stack another box on top and connect it, and now you have a 2U. Maybe you need another one. You have a 3U. Or you can take 3 and attach another 3, and then you have a 6U. And those can be lengthwise, they can be side by side. You can build out the shape as you need to suit the avionics and space systems and technologies you plan to pack into that satellite as you wish. Now, the reason these were created was to save on costs back in the day, and still today, but if we look back a bit, 20, 30 years, and really don't have to go back even that far, just pre-SpaceX, I guess you could say, the cost of putting just a single pound into space, I believe, and I could be wrong here, but I believe it was around $10,000 a pound. Now, a CubeSat more than likely is going to weigh more than that pound. Now, they can be pretty light or they can be pretty heavy. Again, that's going to depend on the type of hardware that you install inside the CubeSat. But it doesn't have to be expensive. Now, if you go back and listen to some of the other podcasts that we've done here, we talk about kind of COTS, commercial off-the-shelf systems that you can go out and buy and build your own kind of computers and that can survive in the harsh atmosphere of space. There's different shielding techniques, there's programmable solutions to do this, or you can go hardcore if you got a lot of money and buy some of the radiation hardened equipment. Now, I don't advise that. It's super expensive unless you're sponsored by somebody or got a major contract. To me, that's a bit of a waste of money. Now, obviously it comes down to the nature of the research you are doing and how resilient you need it to be. But what I'm getting at is you can do this for a pretty cheap cost. A lot of these are throwaway solutions, meaning you're not getting them back after you have launched this into space. You'll receive your telemetry, and then it'll more than likely either stay up there forever and fly around until it bumps into something one day and becomes space garbage, or it's going to burn up in the atmosphere as it slowly builds up all the particles on its front edge as it blasts through low Earth orbit. And then, eventually just falls back to Earth, burns up, and you get a nice little streak of glowing metal in the sky. Now, there has been some research into what materials you can use to make one of these CubeSat structures. So that is the first thing you're going to start with, typically for a CubeSat, is the structure. What do you need to house the equipment you're going to put in it? So you decide whether you need a single U or a 2U or a 3U. And I went and built my own. I wanted to see what I could do and how cheap it would cost, to build one of these, or how cheap I could make one, and maybe make kits to sell to other people. And I decided to take the approach of very thin aluminum that is laser cut and then bent. That way I could remove the cost of CNC, which is extremely expensive unless you have your own equipment. And while I do, getting something that is cut to the tolerances I was hoping for just wasn't working how I expected. So I used a company called Send Cut Send, and it's not sponsor of the channel or anything like that, but they're super awesome to work with, and you get a little bit of candy when you order something from them too. But I had them laser cut some parts for me, and they also bent them, and they can tap them with threads as I specify. And then they sent those parts to me, and then I assembled it here. And I actually built myself a single 1U CubeSat. And the total cost of that for all the parts, I believe, came around $80 some or so. So that, relative to what it could cost for a structure of a single U CubeSat online, you're looking anywhere from, the hundreds to thousands plus, depending on the equipment and features of that hardware. Now, there is more to it than just having a metal structure. You do need other little mechanisms and switches put in there that help keep the power turned off until launched, and these little sensors for that as well. And then you need to have a system built in that you can then load your structure up and affix hardware to it such that it will survive the launch itself. And as we've also mentioned in other episodes, we've talked about the harsh environment of not only space, but to get something into space itself. It's a rough ride. There's a lot of vibration in that, and yes, there are solutions to help absorb these and whatnot, and it just depends on what suits the needs of your experiment or your hardware best. So what I did is I built this out, and it was a lot of fun. I had a structure in front of me. I actually have it sitting on my shelf, and just enjoyed putting little pieces of hardware in there. I used a ISP32, or I believe that's what it was. There's a little control board that has Bluetooth and wireless on it, and it takes a Pi Cam, and I was just playing around. Nothing that I was actually ever planning to launch, but I just wanted to see what I could fit in there, what kind of batteries and stuff like that, how I could co-locate things, and then just for the problem-solving aspect, you have temperature you got to deal with. Can I use the heat from the batteries to help heat the electronics, or do I have to shade the electronics depending on which way it's going to be facing? What is my control going to look like? Do I use reaction wheels? Do I use whatnot? And yeah, there's just a whole bunch of stuff that you could use in this, but it was more for me just a project to do here on Earth that I could play around with the technologies and apply what I was learning in my master's to something physically in front of me. So if you are going through school and you're learning this type of stuff, or you're just a hobbyist and, just interested in space, I definitely highly encourage you to look at the requirements for a CubeSat and see if you can build one yourself. Now, fun fact, there was some Japanese researchers that were looking at building CubeSat structures out of wood. Wood is extremely strong, it is very light, and it burns up very well on re-entry. So that was one option that they were looking at. I haven't done much looking into what that's like nowadays, but I thought it was pretty cool. So back to the different sizes. So these CubeSats can be used from educational purposes from high schools, universities, or to smaller companies or even large companies wanting to throw constellations up into orbit. And they fly in orbits such as Leo and Mio, and some of them even go beyond that. Not as common. I think the most common is more or less probably low Earth orbit. But yeah, so let's talk a little bit how they get there then. So they do need a launch vehicle to get them into space, or they might go up on something like Dragon or a different type of capsule up to the International Space Station. The International Space Station actually has the capability to launch CubeSats from there, or there might be rideshare missions or dedicated launchers as well, like that of Rocket Lab. Now, there are different types of dispensers. The two that I'll mention is P-Pods and NLAS. Those are the most common CubeSat dispensers that are out there today, and depending on which one you go, there are the mechanisms needed in those CubeSats. As I mentioned, little switches that pretty much just like a kill switch inside it, so it knows when it has been launched to then turn on all those systems. Maybe your mission, you want it on the whole time. It depends on if you have an internal power source that can provide the power it needs to get to that point, or if it is something that's solely going to run off of solar panels. A lot of these systems use solar panels. Batteries are heavy and cost a lot of money for these purposes, and a solar panel can give you, I won't say unlimited, but more or less unlimited energy as long as your systems can operate on the voltage provided from your solution and that you are in view of the sun. So you'll possibly lose power when you're on the opposite side of the Earth as compared to the sun and whatnot, or it depends on your orbit, but it's probably the best bet. Now, what about the components and subsystems? So the structure, as I mentioned, typically an aluminum frame, but you might have some more interesting solutions out there, such as those from the Japanese scientists that were looking at wood, and I thought that was super, super cool and an interesting take at space materials. So outside of that, you have your onboard computers, radios, and sensors. Obviously, you're going to need something on there that is going to be able to communicate all the telemetry that you are receiving back down to Earth so you can make use of it and actually get some useful data. If you don't do that, you better have a plan on getting that bad boy back, and it's going to be quite difficult because re-entry is not as simple as it may seem. You will more than likely burn up on your return. And then onboard computers, we've talked about things like Arduinos. You can use any really MCU, single board computer, anything like that, as long as you build in the type of redundancy you need, or you might just take the risk of having a single unit go up there and hope for the best. And maybe you don't even need your mission to last that long. Maybe you'll get all the data you need in the first 30 minutes, and chances of the radiation and space environment destroying your computer in that time is, you've calculated to be more viable than maybe not, and who knows. So it all depends on your mission and what you need and duration of your mission, for sure. So if you need something that's going to last a long time, redundancy, absolutely. And if it's something that maybe you only need to make one orbit, so flying, I think in orbit's like 40 some minutes or so. No, actually it's 90 minutes if we're thinking of the International Space Station. They orbit once every 90 minutes, so assuming same velocity, then we'd be looking at about 90 minutes per orbit as well. So let's continue on then. So power, we already kind of spoke about. You have solar panels, battery packs, and then how do we distribute that power to those components that make up the CubeSat. So it all depends on your systems again. And then propulsion, so that's going to be an interesting one, especially having something that is so tiny. So CubeSat use things like cold gas thrusters, ion propulsion, and then obviously solar sails. For most cases, you probably don't need any real propulsion system at all, especially looking at a solution for, say, educational purposes or smaller companies, in that you're not going to really need that, assuming your mission is short duration enough and you only need to complete several orbits. So if you do need some sort of reaction system or thruster system on board, cold gas thruster is probably the best and most cheapest option. You could even look at containing some sort of CO2 tanks and have those controlled by some actuators and use those. But I think reaction wheels or some sort of gyroscope is probably going to be the most cost-effective solution just for orientating the spacecraft in orbit, rather than providing some sort of propulsion system and whatnot. That's assuming your mission is to stay in orbit around the Earth. If you're planning something to go maybe farther along or leave Earth orbit, then yeah, solar sail or something like that could be a good use case for that. But yeah, I won't dive too much into that. So then communications. Communication is absolutely key, especially for any type of non-return mission, not just CubeSats. So we need something to get that information back down to Earth. So you'll need some sort of ground station network. You could maybe make use of the DSN if able, radio frequencies. There are some challenges that come along with this because you will have to have approval for specific bandwidths to transmit on, especially at the frequencies or the power needed, I guess, to transmit and receive. If you're just receiving, that's fine on your side. But if you're building a CubeSat and you want to be able to send commands, reorientate, and receive data from it, that radio on board, you'll have to have some sort of approval to do so. Yeah, and then, as I mentioned, reaction wheels, magneto-torquers, sun sensors, star trackers. These are all different types of attitude control mechanisms that you can use on board your CubeSat. So there's that. So let's look at some real-world applications. As I mentioned, your research could have something to do with Earth observation, weather patterns, climate change, climate monitoring, whatnot. You could be doing something that requires microgravity or radiation studies. Now, microgravity is a cool one because you can do some of those. Depending on the exposure duration you need of a microgravity environment, there are possibly some cheaper solutions, such as putting a payload on a rocket like New Shepard, or using the zero-G airplane, or even a free fall on some big like weather balloon styles. Depending on what you're actually looking for, there are some other options that you can do without having to launch something specifically into space. But if that is the purpose of it, that is a great microgravity environment, obviously, and you can get a much longer duration to complete those experiments you're looking to do. So, all right, then you have communication. So there's internet, constellations, emergency response. You could be testing new space technologies before scaling up to a larger size satellite, or you could be working on some proof of concept for maybe a deep space mission. There are the Marco CubeSats that flew to Mars with the InSight lander, so that's another cool option for those that are interested, of course. Now, what are the challenges and limitations? Obviously, you have limited power and computing power capabilities when working with something that is so small. There's also typically a shorter lifespan, and you have atmospheric drag in LEO, as I mentioned. So if your duration plan is longer than several orbits or whatnot, obviously you have to do the calculations to figure out how long you can stay up with no thrusters. But if you do need thrusters, then you're going to have to account for that in your design, and that takes up space. So maybe one U might not be large enough once you start figuring out everything you need to pack into such a small little box. Then you have communication bottlenecks, space debris concerns, there's regulations you have to follow. There's quite a lot you got to get into, but it's definitely possible to do. Many schools do it, and I would recommend, if this is something that you're looking to get into and you are part of a university or a school, reach out to a director, a dean, professor, whoever, and see if you can get them to buy into this with you and turn it into a much larger project that you can get some help with, to help kind of, I guess, reach out to those people or resources that you might not be familiar with, and get somebody with a bit more experience in those fields, so you can focus on the actual CubeSat design and structures and experiments at hand that you are most curious about. And then if you're working with somebody who has experience in this field, they'll be able to guide you a bit better and mentor you along the way, so that down the road maybe you can help someone else out. So the future of CubeSats, well, growth of commercial CubeSat constellations like Starlink style and other small sat networks, or Kipper from Amazon, these are filling up low Earth orbit and mid Earth orbit. And there's a lot of companies now that are looking at building out CubeSats, mostly just because of their cost. And as computational power becomes more readily available and cheaper and smaller, you can fit more things into a compact size, and it just makes cheaper launch abilities into orbit, or it's cheaper to get these systems into orbit now. So as I mentioned, I think it was like $10,000 a pound back in the day. Well, now you can do that for about a kilogram. So a bit more weight to it now for the cost, and that's obviously going to just keep decreasing as launch cadences continue to go, and reusability of launch vehicles and more private sector companies come into play here. That's definitely going to help us get there for cheaper costs. Now, there are sometimes you can find grants and such for these types of projects, so definitely keep an eye out there. You can check out NASA, ESA, and other communities that might be able to provide some insight in those areas. But yeah, that's more or less all that I had for you folks today. I just want to talk a bit about CubeSats. They're an interest of mine, and like I said, a good platform, even if you don't plan to launch something into space, just to work with and experiment at home. It's a lot of fun building a structure like this. If you enjoy building computers, working on cars, or anything like that, building something with your hands, this is a fun way to do it. It's kind of meticulous, but if you're into this type of thing, it's a lot of fun. And when you're done with it, you can have a fully functioning CubeSat sit on your shelf and say, hey, look, this is what I built. It may not have gone to space, but it could. And it's just a fun way to hone in your skills, whether you are a mechanical engineer, a software engineer, electrical engineer, you name it, any type of engineering STEM field, even just math, like all these fields all come together to make this type of technology useful and plausible. And so there's nothing in this realm that is really limiting you, I guess is what I'm trying to get at. Like, just have fun with it, enjoy it, and see what you can do. So yeah, definitely check out Send Cut Send or any other of those providers that allow you to have materials cut and sent straight to your door. They bend them so it helps you from not needing to have the equipment on hand. They'll even 3D print for you if you don't have a 3D printer and anything like that. You can use things like SketchUp or Fusion 360. I think Fusion 360 has a free license, at least they used to, for just hobbyists. Or you can find some designs that are out there that already exist and print those off and then build on top of that and just have some fun. If you guys are interested in the designs that I have, I'll see if I can dig them up again and make them readily available to you. Just throw a comment in the podcast here and let me know what your thoughts are. If you want them, I'll find them. If not, that's fine. There's lots out there that you can have fun with. But look at the cost of what it takes to get a COTS version, that's commercial off-the-shelf version of a CubeSat, versus what it cost me to do one myself. And I followed all the specifications to build this out so that it does meet what is required to launch one of these into space. And I was able to do the structure for around $100, whereas if you go to buy one, you're looking hundreds, thousands of dollars. Hundreds or thousands, not hundreds. I guess you go up to hundreds of thousands. Who knows? There's always something more expensive. Anyways, that's it. So again, just want to get more people involved in this industry, really, and really have some fun with it. It is a fun industry to be a part of. It is exciting, and there's always something going on. But it's cool because you can bring aspects of all areas into one and really enjoy it. So with that, I hope everybody enjoyed this podcast episode today here on CubeSats, and I hope you enjoy your week and are enjoying your Monday today. And don't forget, stay curious, keep looking up, and enjoy your week, everyone. Take care.